All right, so next to pyramids, we have a cone, which is similar in that it kind of has that pointy top and a single base. So I'm not going to have, a circle on top and a circle on bottom. Now I say that assuming you know what a cone is. What I think about when I talk about a cone is like a paper cup that you used to see at like an old school water dispenser, those big blue bottles. There's all those little paper cup cones. So that's what we're going to try and find the surface area of. So kind of get a picture of that in your head. This next picture that I'm going to show you guys is a net for a cone, and it looks a little weird. So I'm going to explain a couple of things that are going on, and then we'll talk about how to find the area of that. So here's my net. I've got my cone over here on the left, right? I've got the blue piece, which is kind of the wraparound part, and then I've got the orange piece, which is the circle that makes up the bottom of my cone, or the top, depending on how you're holding it. Okay, so there's two different things going on here. There is, I got something extra in here that we don't need. There's two different things going on here. There is the radius of the circle, which we have dealt with, but similar to my pyramids, I need that slant height. I don't need to know how tall the cone is through the middle, from the middle of the circle to the peak. I need to know what it is on that slanted piece, which isn't typical of what we normally do in geometry. So what I'm looking at here are my two measurements that I need. I need the radius and I need the slant height, or what I'm going to call L. Okay, now piece-wise, what we're looking at, when I flatten this thing out and I start looking at the pieces to try and make my formula or whatever for my area, I've got a circle, which we've done a whole bunch. We know how to find the area of a circle. We're going to use 3.14 again for pi. Just keep that in your pocket there. And the blue part is kind of the tricky part. That is part of a bigger circle. Kind of, it's a little flat in places, but so I've got this big circle, and I just want that one little portion of it that kind of wraps around and comes to a point. Now, I used to do a kind of a project in class where we started with the nets and we made these shapes, and the cone was one of the hardest ones because you had to not fold, but kind of roll this piece together to get it to make the outside of the cone. But that portion of the circle, we're going to find the area of the blue part by taking pi times the radius times the slant height. Now, a long time ago, I used to know how that was pi RL for that blue piece. I've forgotten that. If you're interested, I could probably try and find it and we could talk about it someday. But for now, our formula is going to be, for the surface area, is right here. Pi r squared for the circle plus pi RL for the cone's outside piece, or what's called the lateral area. Okay, so we really just need two numbers and a calculator, and we can kind of hit the ground running on these. All right, so I've got a cone that has a radius on the base of 6 yards and a slant height of 10. So that is pi r squared plus pi again times r, which is 6, times slant height, which is 10. That's it. Pi r squared plus pi RL. And then you just type it on in. Yeah, I don't really have any advice for that. So 301.44, so I'm going to make that 0.4, round it to the nearest tenth, square yards. Okay, they're super straightforward. The only thing is if you're given a diameter, like this one, just keep in mind the formulas call for radius. So what you've got to realize, don't get in too big of a hurry doing these, is that diameter is split into two 3-inch pieces for the radius. So when I set this up, pi r squared plus pi r L. Okay. I don't know if this would make anybody's life easier, but when I do these, like my numbers, or if they're small enough, I just do those in my head. So that way I'm taking 3.14 times 27 instead of times 3 times 9. It doesn't really save you anything, just a couple of keystrokes on your calculator. All right, that one is 339.12, so rounded to the nearest tenth is 1 square inches. Don't forget your units on these. They're super straightforward, and I'll see if I can't find a video of somebody else explaining why that pi RL works.